You are staring at a scraper log and it's a wall of red. 403, 429, 503, all mixed together, and the instinct every single time is the same one. Rotate the proxy, hit retry, hope it clears. The instinct works often enough that it becomes a habit, and the habit is wrong. Those three codes are not the same problem wearing different numbers. They come from different parts of a target stack, they get triggered by completely different signals, and if you react to all three the same way, you either waste good IP addresses or you keep hammering an address that was never the problem to begin with. I run real proxy farms, dozens of servers, hundreds of modems and SIM cards cycling through carriers, feeding production scrapers that run around the clock. I've watched error rates spike at 3 in the morning and had to figure out, half asleep, whether the fix was more IP addresses, a slower request rate, or just leaving the target alone for 20 minutes. This isn't theory from a blog post I read once. This is what actually happens when you're the one paying for the IP addresses and the one who has to explain why the scrape rate dropped. So let's go through the three codes properly. Before any of that, one thing needs to be said plainly. None of what follows is about beating a site's defenses or finding a clever workaround for a CAPTCHA or a terms of service. It's the opposite. It's about reading the signal a target is sending you correctly so you can back off when you should, slow down when you should, and stop blaming your proxy pool for a problem that was actually a config mistake on your end. A scraper that respects what these codes are telling, it stays inside a site's terms far more reliably than one that just rotates blindly and hopes. Start with 403, forbidden. This one usually means the request itself failed some kind of check before the server ever got around to thinking about rate limits. Something about the shape of the request looked wrong. That could be the TLS fingerprint, the little handshake signature your HTTP client leaves behind, sometimes called JA3 or JA4, not matching what a real browser produces. It could be the order of your headers, or a missing header like accept language, not lining up with the user agent you declared. It could be that the IP itself sits in a known data center range the site has decided to block outright. It could also be a bot management vendor sitting in front of the site, something like Cloudflare, Akamai, Perimeter X, or Datadome, scoring the whole session as automated and cutting it off. Here's the part that trips people up. A 403 is often not about volume at all. You can get a 403 on your very first request from a brand new IP that has never touched the site before purely because the fingerprint was bad. So if you rotate to another IP from the same subnet or the same proxy type, you'll usually just get another 403 because the address was never the actual problem, the request signature was. What actually helps here is matching your HTTP client's fingerprint to something a real browser would produce, consistent header sets, a correct TLS stack, and using a class of IP the site hasn't blanket rejected. This is exactly why residential and mobile IP addresses cost more than data center ones. It's not that residential or mobile IPs are invisible, nobody's is. It's that they sit inside ranges carrying real subscriber traffic, so a site can't just block the whole ACE end without also blocking its own paying users, which gives that traffic a kind of built-in cover that data center ranges never had. Next, 429, too many requests. This is genuinely the most polite of the three codes, because the server is explicitly telling you it noticed your pace and wants you to change it. The catch is figuring out what key it's actually counting against, because it is not always the IP. It might be counting per IP. It might be counting per session or per cookie. It might be counting per account if you're authenticated. Or it might be tracking a device fingerprint that follows you across IP addresses, which is a much harder thing to shake by just swapping proxies. If the limit really is tracked per IP, rotating genuinely fixes it, because the counter resets clean on a fresh address. But if it's tracked by fingerprint or by a session cookie, rotating the IP does nothing at all, and you get 429S on the brand new IP almost as fast as you did on the old one, because the server is following a signal that survived the rotation just fine. This is a trap I've watched teams fall into more than once. They see 429S, assume it must be IP-based, go buy a bigger pool, and the error rate barely moves. The correct read on a 429 is to slow your request rate down and check whether the response includes a header telling you exactly how long to wait, usually called retry after. Respecting that number is the compliant path, And honestly, it's also the fastest way back to normal service. Faster than rotating through IPs and just hoping the next one behaves better. The server already told you the answer. Reading it is cheaper than guessing. Then there's 503, service unavailable. And this one is the odd case out because it might not be about your scraper at all. It means the origin server, or something sitting in front of it, could not serve the request right now, for reasons that have nothing to do with you specifically. The backend could be overloaded from completely legitimate traffic and shedding load to survive. A CDN or a wave could be sitting in a challenge mode, issuing 503S to everyone while it verifies traffic is real. There could be scheduled maintenance running, or a deploy in progress that's temporarily taking the service down. A site's bot management layer can also hold a connection in a JS challenge state and keep returning 503 until that check passes, which looks identical from the outside to a server that's just struggling. Because a 503 can be entirely unrelated to anything your scraper did, the instinct to immediately rotate and retry as fast as possible can genuinely make things worse if the site is already buckling under load. That's not a hypothetical, that's just piling more requests onto infrastructure that's already having a bad day, from a pool that looks, to their logs, like a coordinated wave hitting them at the worst possible time. The considerate response here is exponential backoff. Wait, retry with an increasing delay each time, and cap how many retries you'll actually make before giving up for a while. If a 503 shows up constantly across every single IP in a large pool, that's a strong signal the origin is down for everyone. Not blocking your scraper specifically and hammering it faster is just adding weight to something that's already sinking. Slow down and check back later. Here's the part that makes all of this messier in practice. None of these codes are standardized the way the HTTP spec pretends they are. Plenty of sites return 403 for what is functionally a rate limit, because they don't want to leak how their rate limiting actually works to whoever's poking at it. Other sites return 429 for what is really a permanent IP ban, specifically to avoid tipping off a scraper that the block is never going to lift. Cloudflare's own challenge pages have historically returned 403 for a failed JS challenge that has nothing to do with the IP's reputation at all. So the status code is a starting hypothesis, not a verdict, and you confirm it by watching what actually changes the outcome. If switching IP class, say data center to residential, or residential to mobile, is what fixes it, the block was IP reputation based, which lines up with a typical 403 pattern. If slowing your request rate down is what fixes it, it was a rate limit, and that's true even if the site happened to return a 403 or a 503 status code instead of a 429. Codes lie sometimes, behavior doesn't. If waiting fixes it regardless of which IP you're on, or how fast you were going, it was most likely a transient server condition, which lines up with 503. The way you actually turn this from guesswork into a real diagnosis is by logging the response code alongside the IP that got it, the request rate at that exact moment, and whether a plain retry with nothing else changed happened to succeed. Most scraping frameworks make this trivial to bolt on as middleware, and it pays for itself the very first time someone asks why the error rate spiked overnight. Now for what this actually means for how you build a proxy pool. If your targets are throwing a lot of 403s at you, adding more IP addresses to the pool does nothing if they're the same class of IP the site already blocks on site. Residential or mobile IP addresses, sourced from a network with genuine subscriber diversity behind it, are what address the fingerprint and reputation problem a 403 usually represents. Throwing more data center IPs at a data center problem is just spending money to get the same wall of red faster. If your targets are throwing a lot of 429s at you, the fix is architectural, not just a bigger shopping list. Request pacing, concurrency limits per IP, and actually respecting that retry after header when the server hands it to you. Buying more IP addresses to spread the same total volume across a bigger pool can work, but only if that rate limit is genuinely tracked per IP in the first place. Test that assumption in a small controlled way before you spend real money assuming it's true, because half the time it isn't. If your targets are throwing a lot of 503s at you, look at your own retry logic before you touch the proxy pool at all. Aggressive, immediate retries fired across a big pool during a 503 storm is exactly how you turn a site simply having a bad day into a site's operations team, noticing a very specific, very coordinated looking traffic pattern spiking right when they're already struggling. That's not a good place to end up, even completely by accident. And it's the kind of thing that gets an entire IP range flagged for everyone using it, not just you. None of this guarantees a scraper avoids blocks, and I want to be straight with you about that, because no proxy type and no pool size makes the scraping operation undetectable. Bot management vendors combine dozens of signals well beyond just IP and rate, behavioral stuff, mouse movement patterns, timing between actions, and a well-run detection system can flag a session on behavior alone, regardless of how clean the IP looks on paper. Anyone telling you a specific proxy or trick makes you invisible is selling you something, not describing how any of this actually works. What correctly reading these three codes actually gets you is a scraper that fails for the right reason. One that backs off when it should instead of digging in, and one that doesn't burn through a proxy budget trying to solve a problem that was never about the IP address in the first place. That's the entire game here, spending your money and your IP addresses on the actual problem instead of the first guess. It sounds simple written out like this, but I promise you, most teams running scrapers at scale are still just rotating and hoping. If you want the fuller breakdown of this, the actual reasoning behind it, and more explainers like this one on how proxy-based scraping really behaves once it hits production, there's a companion article that goes with this video, and I genuinely read it before you touch your retry logic. I run the proxies behind real scrapers myself. The full written guides and the proxy setups I actually use are at proxyscraping.org. Full written guides and tested proxy picks are waiting for you at proxyscraping.org. So go take a look and subscribe if you want more of this.